Hey, what's up guys? Today we're going to be going over metatables. So first I'm going to create a script. We're going to delete this line of code. We're going to be going over a few of the meta methods. We're going to be using underscore call. This basically makes it so you can call the table just like a function. And then next we're going to be using underscore index. This copies a table. And then we're going to be using underscore new index. This allows you to intercept any keys being set. So for example, it'll look like this. You know when you set a table, so T is our table, we'll set a key, so we'll say hi is equal to true. That's basically it. So we just intercept this. And we're going to be going over some of the, I'm going to turn my audio down. We're going to be going over some of the methods that you can use. Raw get, some of the functions actually that are built in, and raw set. So basically both of these are setters and getters. This one's a getter, this one's a setter. What it will do is bypass the new index or any other meta methods. There's also raw equal, that's for the equal meta method. We won't be going into that, but you can actually do operations on a table and make your own functions for those. So to get started, we're going to be making a module just so everything runs all at once and then returns what we want. So once we have a module, we're going to name this, we'll be working on a data system, so we'll name this local data is equal to a table. This table will have everything inside of it. So we'll say function data.new. Doesn't matter what the name is. This will just be our first method that will return this table full of methods. So it'll be like local self, because self's a keyword. You can override it, you could change it. It's just like another variable. It's just, actually self is not technically a keyword. It's just a variable that is passed through tables or functions in tables. So if you were to have a function like this, it would include self by default if you bring self through. So if I were to be like data new, that would use this first part. It's analogous to this. It's the exact same thing as data.new passing data through. The first argument will always be self, but that's hidden. You don't need to include that. Just a good thing to know. You can say local self is set metatable. We're going to create a new metatable. We're actually going to make a new table inside of this metatable, and we're just going to copy using, remember we had right here, copies a table. We're going to copy the data table and all the functions and all the variables inside of it. We're going to say index is equal to data. And then we can basically add anything inside of this table. So we can say self.data is equal to another table. Thing is, if you were to run this function, let's make this a dot so it doesn't include self. If you're going to say local player data is equal to data.new, it won't return anything. So we want to return self itself. We don't have the table yet, so we're going to do return self. That way we have self. So we could say print player, actually we're going to do a test. We're going to say new table made, here is player data, or here is data. We're going to print player data dot data, since we made it right here. Then I'm just going to show you an example with the old table. right after we do this. We're gonna say old table made, here is data, and we're gonna, instead of saying player data, we're gonna say data. So data.data. We gotta actually require this table, so we're gonna say require script dot module script. We'll see something come up. So you can see new table made, here's data. So it served us data, but the old table, yeah, I'll copy this in just for an example. So the old data does not have access to that table because we created an entirely new table right here. It's pretty useful. So you could do multiple instances. So let's say you wanted to create, let's say there's 3 players that join the game. I'm just gonna mimic player.added event. You can make this 3 times and it won't collide with each other. You'll just have your own separate tables for each person's data. So now that we got that addressed, let's just delete this. And from here, we can add things into data. So we can say coins is equal to 1. There's an interesting thing. Instead of using all these commas, you can actually just use semicolons. It looks nice. I do it all the time. You can make an inventory is equal to another table because we want to have tables inside of the inventory. Let's just say pets. We'll have a pet table. Let's just put semicolons there. We'll save some work for ourselves. And so now that we got this, we're going to actually play around with meta methods a little more. So we're going to say data.__call is equal to the function. We're going to include this as self. I actually got to print self. So we're going to see if this works. Basically, the concept is all we have to do is call data. That's all. Attempt to call a table value. So it's not setting. We need to figure that out. So we could say data. Or we could say set metatable. Let's just use this. Get another table inside of here. And then we can say data, because that's the table that we're setting. And close that. See if that works? Yeah, that works. So it returns our data table. And it has a new function and everything. So we can actually use this. We can say return self. And let's say we wanted to actually make a new piece of player data for the player. So we can say data.new. We're going to actually touch on var args. So variant arguments are simply ... That just goes on with the arguments. You don't need to keep making friggin' arguments over and over again. You don't need to do this. You don't need to do that. You could just put a ... We're going to put one up here because we're going to pass whatever we need over to here. Then we're actually going to pass ... into this function again. And let's say we want to pass a player's name. So we can say Bob. And from here, since we know it's the first argument that's being passed, we can say self.player name is equal to unpack. We're going to unpack the var. We're going to put the var args into a table, and we're going to unpack those. Actually, we're going to make another thing. We're going to say local args are equal to unpack this table. Actually, we're going to say local player name. I keep changing my mind. Local player name is equal to unpack. So everything is added here will keep on being added. So if I pass another argument, let's say lie, right? The second argument that's passed through data from Bob, if I say true, say I'm lying, lie will be right here. So let's just set self.player name to player name. See if this runs. It's not going to print anything, but just print something to just verify. So we can say print player data dot name or dot player name. Bob. See? Passed right through. Alright, so we're going to touch on the new index actually. So, now that we got all this addressed, good, we're actually going to use a new index. So we're going to set, inside of this, you can use multiple meta methods. Since it's a table full of meta methods, you could just put as many as you want, or if I can recall, you can put as many as you want. I'm not quite sure, but you can put a lot of them. Underscore underscore new index is equal to function. And of course, self will be passed through, which will be data. And the key and the value. I'm just going to verify that this is correct. Pretty sure it is. Self, key, and value. And then we're going to try indexing the old table. Data high is equal to true. So you can see it pass through. I'm just going to do a little bit of a test, see if this actually works on player data. Should copy its meta methods, 100% sure. And Cole was wrong, the meta methods don't pass through. So we would actually have to set this in this table since we're creating new meta methods. It's overriding it. So we have to set new index right here if we wanted to. But basically what we're going to be doing is using the underscore underscore new index, and we're actually going to make our own cool little fancy debug library, and we're going to tie all this together that we've been learning. So the default debug library, you can do print debug dot profile began, and then if we wait 1 second, we can say print debug dot profile end. It's just a way of debugging, setting a marker. So just returns a function. Actually, I have to. Pretty sure it's a function that you have to do. Oh, you need to create a label. That's test. So we create a label. So it says profile end, no active annotation. Anyways, we want all these methods. Let's say they worked. We want to use the debug library, and we want to extend upon it. So what we'd usually do is just say function, let's get rid of all this. Function debug, because that's already declared and it's all global. Debug dot test. So we're creating a new function. We're going to say print red! Exclamation mark. Let's see if this works. Attempt to modify a read-only table. Huh. Weird. That's not actually built in. That's because of new index. And underscore underscore meta method, something like that. But it stops you from even, declaring anything. So, So what we're going to do, we're going to make our own debug library. So we're going to say local debug is equal to set Metatable. We're going to copy the debug library. Remember how to copy? We use underscore underscore index. We say is equal to data. And actually, we're going to make our own. We're going to make a new table. We're going to say debug underscore underscore index is equal to debug. And then after that, we're going to make a new meta method. Say underscore underscore new index. Well, actually, we're going to leave it there. And then we're going to see if this runs. It copied the debug library. Let's see if the debug library works. print debug.traceback. Huh, it printed the current line. Ooh, that's interesting, isn't it? It still works. We can actually add our own methods onto this. So let's say we want to create a method called test. We're going to return two things. We're going to return hi, or we're going to return true, and then we're going to return data, just in case we need data. We're going to return two of the arguments, and I'll show you how to access both of those. It ties into this, the whole unpacking var args. We're going to get rid of this lie thing, so I'm not lying to you. Okay, so keep that there. Then we're going to say we don't want debug to be a separate variable. So what we're going to do is actually make it part of data. To do that, we're going to use the new index. So we're going to say if the key is equal to the name debug, then data.debug is equal to value. Thing is, we need to actually make our own setting for this now. So we're gonna have to say else, because if we tried right now to say data index something, it won't return anything back to us. So we have to make our own. We're gonna have to use raw get. So we're gonna use raw get, and we're gonna say data key value. Pretty sure it's just key. Return. We're gonna return this. Also, we're gonna return debug. We're gonna test this out right now. So we're gonna say data debug is equal to debug. We want to implement that in, and we're going to say data, or we're going to say print data. I'm cool. We're also going to set something. We're going to set I'm cool. See if this works. Uh-oh, an error. C stack overflow. So let's check out what this is. It's printing self and key. Else data.debug. Okay, we could say self. Compromise a little bit. So why is it running over and over again? It's a strange one, eh? Well, c.debug is equal to value. Okay, seems simple. Huh. Let me check what I did before, because I did use this before. In my debug library. I created my own debug library, and I did use this exact same thing. Actually, I used it in my data library. That's what I used it for. So, yeah, it's raw set. Actually, __ index will return stuff to us. So we need to return everything as given on __ index. Because we're going to copy this table anyway. So we'll do that. So __ index is equal to function self and then the key. I'm actually going to put that down there. Is equal to, and then we're going to return the exact same thing down here. And instead of getting, we're going to set. So we're going to say raw set self key and value. Perfect. Now it should run. We actually need to, instead of returning it, because it returns over and over, I'm guessing it's in a recursive loop, so we don't want that. We just want to get rid of all returns and __ new index. we're getting another error. See Stack Overflow, same one. So what's the problem? Data debug 25 is instantiated on 42. If key is equal to, then do that. Let's check back what I did. So what we did here, if not value, then value is equal to debug. Raw set key, data key, maybe I'm setting it to self, and it keeps setting over and over again. Yeah, I need to do it before the meta method was added. So we're going to say if key is equal to data, and then we're going to say if not value. We're going to move all this back up. We're going to move it right before we do the whole thing. If not value, so if debug is set to something else or set to false, we're going to say value is equal to debug. And then down here we're going to say debug.value or data.debug is equal to value. Instead of setting to self, we're going to do that. We're going to get rid of that. We're going to see if it works. It is going to work. Another error. Same one. Just got to debug this. So why is call? Maybe if we get rid of call. It's all about debugging, checking it out. See Stack Overflow. See Stack Overflow. Let me check this out one more time. So we use raw sets on data. When do we use table? Only when we print. Debug is equal to value. So, oh, okay. So we recursively say, right here, we're recursively calling the new index value, or new index meta method. So there's two ways around this. We can say if not raw get value, or raw get data key. That's all. We can actually just put this in brackets. Brackets are sort of redundant, but it makes things look a little nicer. So this will only run once, right after it's set. And then, well, actually, it'll keep setting. Okay, you know what? We'll just say, since we don't want it setting over and over again, all we're going to say, we're going to put this on another line. End. And let's see if our error still exists. It still exists. Okay, we're actually going to do it both ways. We're going to use both ways. We're going to verify that it doesn't exist. And then we're going to say raw set data and then the key. Since we know that the key is equal to debug and then the value. True. So it worked. We just needed to make it so it doesn't recursively run, get an overflow, because it's basically it's basically a recursive function that keeps running and running and running. Okay. So now that we established that this works, we can say print debug.test or data.debug.test. We actually need to call the function, but we do know it exists, and that's all that matters. So it should say true. It's going to print true twice. Yeah, true, and then the table, which is exactly what we programmed in. Perfect. Perfect. Amazing. So now that we have all this, it's all good. We're going to delete those two lines. It's just some basics on metatables. You can also, I'll go over methods real quick. So you can say, let's say I want to add a pet to my inventory. So we can say, we're actually going to be using ID counters because that's a really good way of keeping track. So we're going to say local ID counter is equal to 0. We're actually making a meta method in data. We're going to say local data new UID. which is a universal identifier. So new UID, or you're going to say it's actually a unique ID. New unique ID. Like that. There we go. So we're going to say self, because self's already declared, and all the methods over here are over, like the self will be to the new table since we're copying that table. So we're going to say self.id counter plus equal. That's basically self.id counter equal self.id counter plus 1. It's just a shorter form of saying it. It's in Lua U. You can't do this in Lua. Regular vanilla Lua. It's only in Lua U. Return self.id counter. That's basically it. So actually, we're gonna go one up. We're gonna say we want the player ID too. Actually, we'll just use player name. We're assuming that each player has a unique name, which usually they don't. You would use a player ID since that's set in stone, whereas a player name isn't so set in stone. Someone can change it. Everything can happen. Usually use a player ID. So we're going to concatenate this. So we're going to say, or put a bracket around this, and we're going to say toString dot dot dot, and then we're going to concatenate the player name. But actually, we're going to use string.format because it's awesome. .format. We're going to make our own format for this. So it would be %d, or yeah, %d, and then in between that we're going to separate with the dash, and then %s since it's a string that we're using. And then we're going to put our parameters in. Player name, actually self.player name. Ooh. That should work. Let's make a new ID. So we'll say player data. So all the things are there. Got another error. Let's check this out. Perform arithmetic add nil on a number. Player data new self.data. So that's where our ID counter is. We're going to save the ID counter every single time. Assuming that you would save it, you would just use update async and return self.data, because that's where all our data is. Super efficient, super great. Pretty much what ProfileService does, but you're making your own ProfileService. You don't want to use that. So we're going to start printing debug tests. So we're not all over the place. We're going to say local UID is equal to this. Print UID. So in the console, we have 1-Bob. We're going to use that for items. So next we're going to make items. Just copy this line so we can use it later on. Comment that out. So we're going to say function data add pet to inventory. And we're going to have a pet name. So we're going to say if pet name, then we're gonna copy our UID. We're gonna put that right here. So in that we have our UID declared. We're gonna say self. Has to be self, not data, because data is the actual table that we're copying from with all the meta methods. It's a little meta, but meta methods. So anyways, we're gonna table.insert, which adds something to a table. It's the same thing as doing t, length of t, which is the length of table, plus 1 is equal to your value. Same thing, but more reliable. Table.insert. Self.data.inventory.pets. We're going to create a new table, and we're going to say name is equal to pet name. Then we're going to say pet ID is equal to UID. And afterwards, we want to return the universal identifier. We're actually going to make another function, since how it will look in the table of pets is like this. It's good for indexing it, but it gets a little complicated. But it is a great method, since if you were to use indices and have a friggin' string name or a table, just use that, everything gets messed up. There's problems with it. When you send the data over, it's just blah. So we're going to use, this is always going to look like this. It's going to look like this. Name is equal to Charmer. And then the pet ID will be something along the lines of Joe 3, 5, anything. So it'll look like this. We'll keep that there, for example. So that's exactly what add pet to inventory. So we want to make another function to get the pet in the inventory. So we're going to say get pet. Just get pet. It's a good name. UID. We're actually going to be using luau to add the number. It looks nice. And we're going to return the table. It's a good way to, type checking is a great way to keep track of what you're doing and everything like that. So basically the colon just makes a different type. So I'm going to be using the type number for UID. Actually, UID is a string. What am I thinking? It's a string. And then we're going to return a table. That's what this does. We can actually make this optional by putting a question mark. Pretty interesting stuff. All right, so we're going to say for index and underscore table in pairs self dot data dot inventory dot pet do, and then if underscore table dot pet ID is equal to the UID, then return the table and the index if we need it later on. Just for removing stuff and everything like that. So once we have that, we're going to say this is just a way of getting the pet. Okay. So we're going to say Playerdata add pet to inventory. We're going to name this one Utah. Why not? And then we're going to say Playerdata. We're going to print the pet. So we're going to say player. Okay, wait. So we return the UID. So we're going to say local pet ID is equal to this. And then we're going to say, we're going to print Playerdata get pet. And we're going to get the pet ID. So this should return the table back to us. Got an error. Table expected. Got an L. Pets. Just had a little bit of a typo. Happens. So we returned everything. Returned the index and the table. So we got Utah and Bob. Perfect. That's a great system. Now that you know how to set that up, do what you will with it. The code will be in the description. Yeah. Enjoy. Peace.